transcendental function, we glimpse the boundless nature of mathematical exploration. Good morning. I'm Giseloy de Gilmo, and alongside me is Dennis Dwight Arias. Today, we thrilled to introduce you the limit of transcendental function of basic calculus.
We'll be exploring key concepts that form the foundation of this fascinating branch of mathematics.
Let's dive in and discover together.
Where x is variable and a is constant, which is the base of function, and it should be greater than 0.
So here is an example of exponential function. Here we have the limit of 3 times 2 raised to the power of x plus 5 as x approaches to 5. So imuna yung kapitin ang 3 times 2. We're going to replace the value of x to negative 1. But first we're going to solve this. Negative 1 plus 5 is equal to 4. Yeah, then 2 raised to the power of 4 is equal to 6. Then 3 times 16 is equal to 48. Money ang answer sa
Another example of exponential function. The given the limit of 3 times 4 as raised to the power of 5x plus 3. So, as x approaches to 2 over 5. So, first we need to substitute first, which is the limit of 3 times 4 as 5 times 2 over 5 plus 3. So, first thing we do is to kuha ni siya kaning exponent ang atong unahon kay we talk about exponential function. So, 3 times 4, then 5 times 2, 8. As we know, kay ang 5 kay kuha ni siya whole number. So, nani siya divisible ng over 1 sa denominator. So, gamiton ta itong ato ang shortcut formula, which is cross multiply. So, naman ni siya yung same diri, we need to cancel, ang nakabilin kay 2 over 1, or which is 2. Then, come to the plus 3, which is the, nakabilin natin kay 3 times 4 as raised to the power of 2 plus 3 equals 3 plus 4, 2 plus 3 equals 5. So, 3 times 4 raised to the power of 5 is, so 3 times 4 raised to the power of 5 is 4 raised to the power of 5 is equal to 1024. So, the next step is multiply the 1024 to the 3. 3 times 1024 is 3072. So that is your exponential function.
Logarithmic function. In mathematics, the logarithm is the inverse function to exponentiation. That means that the logarithm of number of x is the exponent which we must be raised to produce x.
We are here today to tell you some examples on how to solve a limit with a logarithmic function. But before we start, let us walk you through on how to read a logarithmic function.
In exponential functions, this can be read as a squared is equals to 4, while in logarithmic functions, this can be read as log base 8 of 64 is equals to 2.
And now, here are some examples on how to solve limits with logarithmic functions.
Limit of log base 2 of x as x approaches to 8 is equals limit of log base 2 of 8 as x approaches to 8 equals to limit of 8 as x approaches to 8 is equals to 3. So why 8. It's because one of the limit laws stated that limit of x as x approaches to c is equal to c. So, muna, that's why. So we have here the kanangguan. So we have the limit of log base 2 of 8 as x approaches to 8 is equal to 3. So to see if our answer is correct, we have to write it in exponential form. So number base 2, answer 8, and exponent 3. So to check if our answer is correct, we have to multiply 2 3 times. So 2 times 2 is 4. Times 2 is equal to 8. Therefore, the limit of log base 2 of 8 as x approaches to 8 is equal to 3.
Another example would be the limit of log base 5 of x squared plus 9 minus 1 as x approaches to 4. So first, we should substitute our x into 4. As stated by Rule 6, the limit of x as x approaches to c is equal to c. So this would be written as the limit of log base 5, x would turn into 4, so that would be 4 squared plus 9 minus 1 as x approaches to 4. And the next would be to use the PEMDAS. First is to do the parenthesis first. And in the parenthesis, there is an exponent. So it would be written again as limit of log base 5, 4 squared is equal to 16 plus 9 minus 1 as x approaches 4. So then, inside the parentheses is 16 plus 9. So 16 plus 9 is equals to, since it's in a parenthesis, we should prioritize it. So it would be limit log base 5, 25 minus 1. So, should we subtract 1 in here? No, we actually do not subtract 1 in here because 1 is not part of a logarithmic function. So, to actually do this right, it would be as limit log 5. This would actually be turned into 5 only because this is the only function that we have, which is log base 5 of 25. So it would be, the remaining would be 5 plus 1 as x approaches 4. So we should remove the limit now because this is the remaining, so it would be 5 plus 1, which actually is minus 1, sorry. 5 minus 1, which is 4. So the limit of log base 5 x squared plus 9 minus 1 as x approaches to 4, the answer would be 4.
Let's move on into the trigonometric function. In finding the limit of trigonometric function, there are several things that you need to remember and identify. First, you need to remember the unit circle. So what is the unit circle? A circle is a circle on the Cartesian plane that has a radius of 1 unit and is centered at the origin 0, 0. The unit circle is a powerful tool that provides us with easier reference when we work with trigonometric function and angle measurements. This is the unit circle, and this will be the basis of finding the coordinates. And the second thing that you need to remember is the degree it converts to radians is you need to multiply the given number into 5 over 180. And radians convert into degree, you need to multiply the given number into 180 over 5. Lastly, this table is where we will base the final answer by using the coordinate x and y. Cosine is simply equals to x and the sine is simply equals to y. And finding the tangent is equals to y over x, and you need to divide it to find the final answer. In second is 1 over x, and you need to divide it to finding the final answer. In cosecant, 1 over y, and you need to divide it to find the final answer. And the cotangent is x over y, and you need to divide it to finding the final answer.
We will give examples in the given or the trigonometric function. So first example is, what is the limit of tangent to 2 pi over 3 plus 2x as x approaches to 2 pi over 3? So the first thing we will going to do is to evaluate the c here. So this will become the limit of tangent 2 pi over 3 plus 2 times 2 pi over 3. So, the next thing we need to do is to find this. The next thing we are going to solve is this one. So, this will become 2 times 2 pi over 3. Since this is a whole number, it has a denominator of 1. So, 2 times 2 pi is equals to 4 pi. Then 1 times 3 is 3. So, we now have the answer for this one. So, the next thing we're going to do is to put this again. So, the limit of tangent 2 pi over 3 plus 4 pi over 3. After that, we will now add the 2. So, this will become, since it has the same denominator, we will simply just add the numerator and copy the denominator. So this will become the limit of tangent 2 pi plus 4 pi is equals to 6 pi. Then simply copy the numerator, the denominator, which is 3. Now that we identify now the radians, we will convert it to degree. So this will now become the limit of tangent 6 pi over 3. So since this is a radians, we will convert it into degree. So this will become 6 pi over 3 times 180 over 5. So we will just simply cancel the pi, then get the GCF, which is this is going to be 1, and this is going to be 60. So 6 times 60 is simply equals to 360. Now become tangent of 360. So by using the unit circle, we will locate what is the coordinate of 360 degrees. So based on the unit circle, the coordinate of 360 is simply 1, 0. So since it is a tangent, we will now base on the table in where tangent is equals to y over x, which is simply equals to 0 over 1. So 0 over 1 is simply equals to 0. So the limit of tangent 2 pi over 3 plus 2x as x approaches to 2 pi over 3 is equals to 0.
So this is the last examples on finding limit of trigonometric function. So limit of cosecant pi over 2 plus x as x approaches to pi.
The first thing to do is evaluate the value of x, which is equals to 5. So, since the value of x based sa unit table, it has the degree of 180. At since the pi in the unit circle is equals to 180 degrees, ato sa recent class sa pi over 2, which is 90. Okay? I-convert mo pi over 2 times 180 over 5. So, since GCF GCF dot 2 and 180 is equals to is 2, Ma 1 na is ka and 20 is ma 90. Cosecant 90 plus 180 is equals to cosecant 90. So, by looking at unit circle, 270 consisted of the coordinate 0, 1. Since we're looking for cosecant, cosecant is 1 over y. So 1 over 1 is equals to 1. The limit of cosecant pi over 2 plus x is equals to 1.
Algebraic function, and I hope you learned something